Quadratics, graphing parabolas. Remember that the standard form of quadratic equation is y equals ax squared plus bx plus c, where a does not equal 0. If we're going to graph the parabola that matches the equation, we can see two important features of the graph by looking at a and c in the equation. The leading coefficient, a, tells us whether the parabola opens up like a smile, a greater than 0. So it opens up like a smile, like this, when a is greater than 0. But if a is less than 0, then it opens down like a frown. The constant, c, is the y value of the y-intercept, 0, y. We can then factor the quadratic expression and use the zero product property to find the x-intercepts. The next step is to use the property of symmetry. All parabolas are symmetric, to find the x value of the vertex. Then we can plug that value into the equation to find the y value of the vertex. This is usually enough information to graph the parabola with some accuracy. All right, so we're going to graph the parabola that matches the equation y equals x squared plus 2x minus 3. So the first thing that we can graph right away is the y-intercept is going to be the point 0, -3, right there. The y value here, or excuse me, the a value here is 1, which is positive. So that means this is going to open up somewhere. I don't know where it's going to be, but wherever it is, it's going to open up, right? Because 1's greater than 0. All right, now what we need to do is we need to factor the quadratic expression. So what we're going to do is we're going to use the box and diamond method. And in the lower left-hand corner goes the x squared term, x squared. In the upper right-hand corner goes the constant. We multiply those together to get -3 x squared. And then the x term goes into the bottom of the diamond. Now, whatever goes here and here have to multiply together to give me a negative. So that means one of them has to be positive something x, and one of them has to be negative something x. Whoops, not 2. That should be an x. Now, whatever we put here and there, multiply together to give me a -3, and add together to give me a +2. So it's got to be a positive 3x and a -1x. And that works. Now we can bring those over, 3x, -1x. And now we have to do the outside, the length and the width of the rectangle. X times x is x squared. X times what is 3x? X times 3 is 3x. X times what is -1x? -1. Is 3 times -1 -3? Yes, great. That means that we can rewrite our original equation as y equals x squared. Oh, sorry. That was the original equation. So it's going to be y equals quantity x plus 3, which I get right from there, times quantity y equals x minus 1, which I get right from there. Now, if I'm looking for my x-intercepts, so I'm looking for x-intercepts, I'm going to make y equals 0, because if the point's going to be on this x-axis, that's what makes it an x-intercept, it has to have a y value of 0. That's the only way that that can happen. So we have y is equal to the quantity x plus 3 times the quantity x minus 1. Now the zero product property says, if we're multiplying two things together, and the product, that's the result of multiplying, is equal to 0, so the product of these two things is 0, then either the first thing needs to be 0, or the second thing needs to be 0. One of those two things has to be true. Okay. So now what I'm going to do is I'm going to subtract 3 from both sides here, and I get x equals -3. And here I can add 1 to both sides to isolate the x and get x equals 1. I should use a different color on that. Let me pick a different color. So here, this tells us the point is -3, 0. There's a point there at -3, 0. And this tells us that there's a point at 1, 0. 1, 0 is right there. All right, so we have our two x-intercepts. Now we can use the property of symmetry, which says that, listen, right down the middle of this parabola, which is going to be a smile, is going to be the line of symmetry or the axis of symmetry. And it's got to be halfway between our two x-intercepts. Any 2 points that are at the same y value, well, the line of symmetry is halfway between them. And so this distance is 1, 2, 3, 4. So those two x-intercepts are 4 units apart. That means that the middle is 2 units apart from each side. 1, 2, 1, 2. So right here is the axis of symmetry. That means that the x value of the vertex is x. That's really, really not easy to see. Let me do that in black. Is x equals, that's also not easy to see. Let's try again. How about we use this color right here? X equals -1. So now I'm going to plug x equals -1 into our original equation. So it's going to be, let's see, y is equal to -1 squared plus, I'm going to have to move this, plus 2 times -1 minus 3. And I'm going to do this kind of all in one step. And if you don't like it, then do the steps and make sure you understand it. But what I'm going to do here is -1 squared, that's 1. 2 times -1, that's -2. So we have 1 minus 2 minus 3. Well, 1 minus 2, that's -1 minus 3 is -4. All right, so here we have y equals -4. So that tells me that when x is -1, y is -4. When x is -1, that's on this line, y is -4, so right there. That's our vertex. So first we found the x value of the vertex. It had to be on our axis of symmetry, which was halfway in between our two x-intercepts. So we plugged that -1 into our original equation, and we found the y value for that point, -1, -4 right there. And we also get a point. This has to be reflected across the axis of symmetry to right there. So that's a free point that we get right there. And now we can create a graph for that. Oh, you guys couldn't see that -3 there. I'm so sorry. So there was that -3 there from the original equation. Sorry about that. So I need to graph this, and it's going to be something like that, and something like that. And remember that this isn't a point down here. It's a nice smooth curve like that. It's hard to tell though with that big point there. So that is graphing a parabola.